Hello. Today we are going to be talking about adding and subtracting fractions. And really there's only one main note to write down. When you are adding or subtracting fractions, there's one thing that you always need. You need a common denominator. So you need a common denominator. Why? Why do you need a common denominator? Let's do an easy example. I think you'll see why. If I did a half plus a fourth, if I just added those numbers up, like I didn't know what was going on, 1 plus 1, 2, 2 plus 4, 6, that would get a third. Let's just look at what we just did here. If you had half of a pizza, delicious, and a quarter of a pizza, if you add those two together, right, it should look like you got your half plus your quarter. That's not what a third is. So this is not right. That's why it doesn't work. Okay? Here's why you need a common denominator, because we're counting pieces. Fractions are pieces of things. They're parts of things. So if you have a half plus a fourth, if you want to count these all up, you want to cut them into the same size pieces. Right? If you cut these all into fourths, you could count. I have 1/4, 2/4, 3/4. And that is the correct answer. Right? So that's why you're going to get a common denominator. You're going to change a half, just like we did in this picture, into 2/4, because that's the same amount, it's just cut up differently. So you're taking the same amount of pizza, you can think in your head, you're just chopping it up different. If you eat half a pizza, you could eat one huge half, hold that in your hand, or you could cut it all up, you're still eating half the pizza. Now, how did we do this? If we weren't thinking about pizzas, I'm getting hungry. You look at the denominators, the numbers on the bottom, and you try to find a number that they both go into. In this case, it was nice because the bigger number 2 went into, so you can change the 2 into a 4. Now when I say change into, you should be multiplying. So 2 times what gave me 4? 2. So you do the same thing to the numerator. 1 times 2 is 2, and that's how you get equal amounts. Now once you have a common denominator, you keep it, all right, and you're just counting up, adding up the numerator. Okay, so that hopefully shows you why we do it. If you just added normally, like we got our weird answer of a third up here, it doesn't work because you're counting different size pieces. You need to get all the pieces to be the same size, then you can count them up. All right, so let's try another one here. Example 2. Let's say you've got, I don't know, 3/4 and 1/6. So you're adding 3/4 together with 1/6. Ooh, so I'm looking at the denominators, 4 and 6. I need a number that they both go into. Now some people multiply these two together. 4 times 6, 24. You could use 24. That would work fine. You would end up having to reduce at the end because that's not the lowest common denominator. Can you think of a number lower than 24 that they both go into? Here's what I do. I start with the bigger number and I go up by that. So I'm going 6, 12, 18, 24. Wait, 6, 12. 4 goes into 12. So they can both fit into 12. Okay? And now it's like a puzzle. So piece by piece here, 4 times what gives me 12? 4 times 3. So then 3 times 3, you do the same thing here, you get a 9. Now this is a different puzzle. 6 times what? Maybe I can draw it here. 6 times 2, right, gives me 12. So this whole fraction you have to do times 2. 1 times 2, 2. And now we're going to add across. We keep the denominator the same. So we just cut these pieces into 12ths, smaller pieces, right? You add them together. Apparently there are 11 twelfths. All right, nice. Now, what if I gave you two mixed numbers? Let's say 3 and 1/5 plus 9 and 7/10. You could make those improper and then add and then change it back to mixed numbers, or what I like to do is I just keep them as mixed numbers. So I keep the whole numbers there. And then I just deal with the two little fraction parts, kind of just like we were up above. So with the 1/5 and the 7/10, we need a common denominator. Start with the bigger one. Oh, 5 fits into this, so we're good. We can actually use the 10, which means this fraction stays the same. 5 times what gives me 10? 2. So 1 times 2, there you go. And multiply the whole numbers together. 9 and 3 is 12. Keep the denominator and multiply the numerators. 2 plus 7 is 9. We don't have to reduce. We're all set. All right, one more. This will be a little bit harder. 7 and 1/3 plus 5 and 7/8. All right, I'm going to set it up. I'm going to keep the whole numbers, set up the fractions here. We need a common denominator for 3 and 8. We'll go up by 8. 8, 16. Does 3 go into 16? No. 24. Ooh, there it is. 24 is going to have to be it. All right, let's start here with the puzzle. 3 times what gives me 24? 8. So 1 times 8 is 8. Over here, 8 times what gives me 24? 8 times 3. So we have to do times 3 here. 7 times 3, 21. Add the whole numbers together. 7 plus 5 is 12. We're going to keep the denominator. Ooh, 21 plus 8 is 29. Now this is weird. What we just have right here, that's an improper fraction, right? When the numerator is bigger than the denominator, that's an improper fraction. So we need to kind of fix this up. How many times does 24 fit into 29? 1 full time with 5 left over. So this improper fraction is equal to 1 and 5/24. What we're going to do for our whole answer is we're going to add that whole number 1 to what we had here, the 12. So we're up to 13 and 5/24. That would be your answer for this one. Okay? All right, good. So that's adding. Subtracting is the same exact thing. It's still this same rule. You need a common denominator. So let's practice some subtracting here. ... I don't know. Subtracting. What up to example 5 here? Let's turn the page. Okay, so still need a common denominator. And let's just try. We're going to go right to mixed numbers. I think you'll be fine with just fractions here. So let's try 3 1/2 minus 2 1/5. Okay. Well, I do kind of the same thing. Well, there's two strategies. We'll keep them like mixed numbers for now. So I'm going to keep it. And let's get a common denominator for 5 and 2. 5, 10, right? 10 would work. Okay. So 2 times what gives me 10? That's times 5. So 1 times 5 is 5. Over here, 5 times what gives me 10? 2. So 1 times 2 is 2. All right, so now we can just subtract here. The whole numbers first. 3 minus 2 is 1 whole. Again, keep the denominator, and then subtract the numerators. 5 minus 2, 3, and you're done. Not bad. Okay, now let's try one that's a little harder. And you'll see why in a second. So let's do 9 1/3 minus 8 1/2. Okay, it doesn't look harder yet. We'll do the same strategy. Okay, set up your mixed numbers, and now we need a common denominator for 3 and 2. 3, 6. 6 will work. Okay. Now 3 times what gives me 6? 2. So 1 times 2, that's a 2. Over here, different, 2 times 3 gives me 6, so this is a 3. Now, step back here. Look at what's going to happen. The 9 minus 8 we can do. The 2 minus 3 is not good. That's going to give us a negative, but it shouldn't, because look at our problem. It's 9 and some stuff minus 8 and some stuff. That should leave a positive amount. So, you have some options. You can borrow, or you can make them improper. So I'm actually going to show both ways. Okay, when you get to this situation, you have a choice. And some people are going to like one way, some people are going to like the other. It's totally fine with me. You can choose. So let me just rewrite this in both spots. Okay, and you can see the difference. Okay, we'll do the borrowing one first. So what needs to happen is you need to get some more stuff right here on the numerator so that you can take 3 away from it. So what you do is you borrow 1 whole from the whole number. So this is going to get knocked down to an 8. Now you're going to put that 1 whole over to the fraction part, but you're going to be clever about it. So you're going to add 1 over 1 whole, but in this case, because our denominator is 6, we're going to add 6 sixths over there. Okay? So really this 2 now, since if you did it on the side, maybe, we're doing 6 over 6 plus the 2 over 6. So we should get 8 over 6. So this 2 now is becoming an 8. A lot of kids remember it as you're basically just adding whatever the denominator is to the numerator. This is why, but if that's how you want to remember it, that's okay. And on this side, we don't have to do anything. Now we're done and we can subtract the whole numbers. 8 minus 8, 0. Oh, that's nice. And now this, 8 minus 3 is 5. And your answer is 5/6. All right, so that's borrowing. Not too bad. If you don't like that, or that seems confusing, because, see, what's going to happen is you're always going to be adding a different number. It's going to depend on your denominator, so that could be confusing. If you don't like that, you can make both fractions improper, and then you don't have to borrow at all. So to make it improper, you're going to do the whole number times the denominator. So 9 times 6 is 54, plus 2 is 56. You keep the denominator. 8 times 6 is 48, 49, 50, 51. Keep the denominator. Then you already have common denominators. You can just subtract 56 minus 51, and you get to the same answer. Thank goodness. Okay, so you have a choice. You can either borrow or make it improper. Okay? All right, we will do some more practice together. Good job, guys.